Evening, sir.
Can
Evening,
you
sir.
hear me, Jim?
Yes, sir.
Okay. Okay, great. All right. So as we said today, you're gonna do some questions because we went through all the contents of arithmetic and geometric progression. We went through binomial expansion, and only thing is left for you to do is some worded problems involving applications to simple interest, pretty much money problems, some money problems. All right, it's still the same concepts, but it's just worded now. All right, so let me allow you to present your screen. So you can share your screen. I'm just going to copy the questions. All right, so just for warm up, I'm going to give you a regular question to warm up with, and then I jump straight into the real type. So let me copy it here. So this is the warm up question. That's the warm up question. Jimmy,
Yes, sir.
oh, what's coming to your mind? The arithmetic progression first term. What's the letter we call the first term?
Probably
A. So A equal 8. Cool. Put that down. Now, the first, fifth, and the 21st term, how do you find an expression for the fifth and the 21st term of an arithmetic progression?
Sir, Arnold. Oh, never read this progression. I thought it was the geometric.
Yeah, we're going to look at the geometric soon, but they tell us that the first, fifth, and 21st term of this progression, so that's an arithmetic progression, right?
Yes, sir.
Good, that's the nth formula. That's the nth formula of any term. Good. A plus n minus 1d. And that's the formula for which term?
Fifth.
The fifth term. Good. Can simplify it. Five minus one, just put 4D. And then they tell you that those three terms are consecutive terms of a geometric progression. What do you know about a geometric progression?
It's AR n minus one.
All right, so write out those three terms in like a list now. So the first term, 8, comma, then 8 plus 4D, then 8 plus 20D. That would be the three terms that would be the three consecutive terms, right? The first term of the arithmetic progression, which is the 8. The fifth term of the arithmetic progression, which is 8 plus 4D, and then 8 plus 20D. You can't have just 4D. It needs to be 8 plus 20D and 8 plus 4D and 8 plus, yeah. So put the 8 in there. If it is a geometric progression, what do you know? How do you find the common ratio?
You divide a term by its predecessor.
Proceeding, very good. So T2 divided by T1 or
T3 divided by T2.
exactly, but can't you set up an equation and equate the two of them? T2 divided by T1 should be equal to T3 divided by T2, don't it? How are you going to solve that equation now? I don't know if you can draw a line to show that it's a fraction. 8 plus 4D over 8. Yeah, because when you write it that way, it don't look like in the line above that one. Yeah, how do you solve the equation now? How you just get that it's A equal to 8 plus 20D over 8? That's not true. Where did you get the next equal from down there?
Cancel these two.
You can't cancel an equation. You can't cancel when it's an equal. We cancel when it's a multiplying sign. Very good. Cross multiply. 8 plus 20d times. Why didn't just carry over the times 8? Just bring up the 8. Instead of yeah, just cross multiply.
Sorry, what do you mean?
Oh, when I say cross multiply, like instead of you put the divide by 8, why not multiply both sides by 8? So you wouldn't have any more fractions. You get what I'm saying?
So,
Okay. Brilliant. The 64s cancel. You sure you want to square root both sides? You can't square root both sides yet. You have d square and you have d. So that look like a what? When you had an equation and you had x square and x, it's resembling like a quadratic, don't it?
Yes, sir.
They need to factorize.
Done, sir. Okay.
Yeah, that's good so far. That's good. What you gonna do now to solve that equation?
No, sir. Grandma is calling me. Hold on.
Okay, okay, no problem.
Alright.
You can factor out 16, man. Yeah, why factor out 8 when you can factor out 16? If that's equal to 0, what is D? That means either 16D equal
0
or
or
D or
6, 5, 2, 6.
D minus 6 equals 0. So use those now and find D. Good. So that's which one is the value of D?
Has to be 6.
Very good. Because if it's 0, it wouldn't be an arithmetic progression, right? Then the number would just be 8, 8, 8, 8, 8, 8, right? Would make no sense. So here's my question. What if I'd ask you to find the common ratio R? What would you do to find the common ratio R?
I would put in the D here.
Very good. Sharp, sharp. Very good. All right, you know what to do. All right, no, I didn't like the tempo at which this question was done, so I'm just going to give you another one just to get back in the groove. Is that okay?
So,
Are you ready straight for the worded problem? You feel ready or you want one more?
uh, other one.
All right, let me give you another one that's going to be nice as well. Maybe not as much working, but it's just as nice. You really need to use the formula. It's not the formula we're going to use. It's just the sum of the second and the third term. So you need to remember the expression for the second and the third term. All right, so you have to look out for those type of questions as well.
So I'm not sure what you mean.
All right, remember how we wrote out a geometric series. We said the first term was A, then the next term would be
A plus B
for geometric.
geometry.
Yeah.
A R
AR for the second term, then the third term would be
AR square.
very good. So the second and the third term, if you add them, you get 24A over 25. So what is the second term? You sure you want to do that? What does that resemble?
Yeah.
You have r square, you have r, and you have a number without r. What does it that resemble?
Quadratic.
Quadratic. So divide through the a, and then,
I don't want to erase that much.
yeah. So this question, you have to find a, r first, and then you'll be able to find a. Don't worry, it's not that. Look at it. To break down 25, oh, divide through the a, Jamie. Divide through the a. If you don't divide through the a, then you won't be able to solve it. Divide through the a. I know we look solving a, but what you're gonna do is find r first, and then plug in r in the sum to infinity formula. So divide through a. Divide the entire equation by a to get rid of the a's completely.
You have to divide the other side too.
Well, you divide into both sides, but it's just that
Still
0 over a is
zero.
still 0. Yeah, so you're fine. Yeah. So it must be what? To get 25, it has to be what? Two numbers at a time and get 25. 5 and 5. Yes, all right. 5R and 5R. You have to put the 5 in front of the R. 5R. And over the other side is also 5R. All right, now let's see. We need to get 24, 24, 24. Which two numbers can give us 24? That look like 8 and 3, right? But the bigger number gonna get the 8, right? Which one of those values is correct? They get two answers.
Says R is positive. So
Very good, very good, very good, Jamie. Sharp.
find A.
One minus 3/5. That is okay. You sure about that? Remember, you work out 1 minus 3/5 first. Put a bracket around the 1 minus 3/5. Very good. A equal 100. You see how these worded problems are a little more fun, right?
I'm gonna use the word fun.
They're not fun.
Yeah.
Just a little more thinking, right?
Yes, sir.
All right. Now we're ready for the money problems. We're going to build into it. So we're going to start with a relatively easy one. So let's start with a money problem that is arithmetic. Or let's go geometric. Let's go geometric first, since we're on geometric. So there's a money problem. It has 4 parts to it. First thing, what is a A?
It's 10,000.
All right. By the way, what type of progression is this? If it's a 90% of each preceding year, what type of progression is this?
Is geometric.
Very good. What is R?
R would be 9,000 over 10,000.
R wouldn't be 9,000. Your first term is 10,000. Your second term would be what? 90% of 10,000, which is 9,000. So
Yeah,
what is R? What is R?
said 9,000 over 10,000.
Okay, I wanted you to just tell me the 90%. Yeah, but that's right. 9,000 over 10,000. I'm sorry about that. That's right. But they already gave you in the percentage. All right, so that percentage is R, 0.9. So now that you know A and you know R, now you can go ahead and see what they're trying to ask you. So like 1995, I'm just going to give you a hint. You can draw like a little table to say 1995. You can call that term one, T1. 1996 would be T2. 1993 would be T3. Just to give you an idea of the years in terms of numbers for your calculations. Yeah, good. You get the idea now. So you'll be able to then calculate whatever you need. So find the year in which your grant falls below 2000. Very good. That's what we want to solve. AR to the n minus 1 less than 2000. Good. And you know A and you know R. But you're going to find n now. When the unknown is in the power, what do you do?
Use log.
Very good. Take the log of both sides. Yes, topics can be intertwined like that. Take the log of both sides. That's crazy, right? Didn't think you'll be doing logs in this topic, right?
Sir.
Yeah, it's really nice. What happened to the n minus 1? Remember, you're going to bring down the power. When you take the log of both sides, remember you can bring down the power and put the n minus 1 in front of the log of 0.9.
I need to look over logs real quick. Hold on.
Repeat.
I need to look over
Review logarithm. Okay.
what is.
All right. Because now you're going to have to divide both sides by. You don't necessarily have to review it right now. Just write down this law for me so you can remember it. Write it to the right side of the page. Remember, log A raised to the B is equal to B log A. That's the law that we use. You remember it?
So,
Yeah, that's the law that we use. Aha. Now look at that. Put log 0.9 in a calculator for me. Tell me if you're going to get a negative or a positive.
a negative.
So when you divide by a negative, what do you do to the inequality sign?
You change it.
Very good. You see how many things you have to be conscious of in this question? A lot, don't it?
So,
Yep, a lot of stuff. You see, if your IA was on this topic, we could have built a question, something similar to this, and we would have done it in two ways. We'd have used sequence and series, and we could have also used compound interest and simple interest formula and show that you still get the same answer. You saw math is nice? All of the topics linked together. That's crazy, don't it?
so,
Yeah. So this same question, you could have done it using simple interest. It's actually just a depreciation question. It's really a loss, simple loss. So n is greater than 16.28. So what is the smallest value for n then? Very good, 17. So which year is 17?
it would be 2017. Wait, no. Hold on.
So year 6 is 2000. So when n is 6, that's 2000. You need to see which year would be when. 2011,
Term
95 is 1. So that means 2004 is 10, right?
2004. Yeah.
And if 2004 is 10, then I add 7 more. Yeah, you're right. You're correct. Excellent. Good. 2011. So that's the year the grant will fall below 2000 US dollars. Good. So you see that this question was actually quite nice, right? All right. Now go ahead and do the next one. From 1995 to 2004, is it S9?
Yeah, 9 years.
No, it's 10 years. It's S10. 95 is year one. That's why I say write it down right there, 1995, 2000 would be year seven, 2000 would be year six, 2001 year seven, 2002 year eight, 2003 year nine, 2004 year 10. Because I was just adding on my fingers. I know 2004 is year 10. All right, so it's S10. Can't give that away. All right, that's good. So $38,742. Now let me see how you're gonna find the total amount for the next 10 years. Let me see what you're gonna do.
Can't be the same amount because
All right, look at this. So to find from 2005 to 2014, remember the sum formula only give you from sum from 1 to n. So what you're gonna have to do is find the sum from 1995 to 2014. How many years is from 1995 to 2014? That's 20 years, right? So find the sum of those 20 years.
then subtract it from it.
Very good. Sharp, sharp. Nice. So you get in the gist now. You see all these ones, you have to be looking in deep to see what's going on.
So
Yep. Right. Wait a minute. Why is there a minus sign in the denominator? You know, I didn't actually check it in the cal. Let me check it in the calculator. 0.9 raised to the 9. Why do you have a minus sign?
Is the R minus 1.
8 times r to the n minus 1 divided by r minus 1. Why is it negative? Let me see. It should be negative. Oh, remember what I said last week? You used when it is whenever r is between 1 and negative 1, which formula we use? We use the other one. E times 1 minus r to the n. That's what is missing from the formula. R to the n minus 1. Oh, there it is. You don't even need to change the formula right there. You actually put it in the calculator wrong. It's r to the n, and then you subtract 1 from it. So it should be 0.9 raised to the 10, and then you subtract 1 from it. That will give you a negative number. Then the negative over negative become positive. So it's r to the n, and then whatever that is, then you subtract 1 from it.
Sure, but in the formula is 1 minus R. So the denominator would be positive.
No, look what I'm saying. Write it with a pencil. Write it with a pencil for me. And not the type, because the type can be. So it is, no, just write the formula on the other side over here. The formula you're using is r to the n minus 1, not minus 1 in the power. Oh, I think you're using the erasable marker. You need to use the draw pencil. So it's the minus 1. Not minus 1 in the power, no. It's just minus 1, regular minus 1. Yeah, over r minus 1. And in the numerator, you multiply it by a, of course. So a in bracket r to the n minus 1. Yeah. So fix that in the formula. That's why there's a negative. So then the whole value is going to change. Yep, that's correct. That's what I got. 65,000. Yeah. But you forgot, you left off. Oh, yeah. It's good. The dollar sign is there. Good. That's good. All right. So how are you gonna find now the number of years that it took to pay 90,000? The sum to exceed 90,000. Very good. Exceeds mean greater than.
Wait, you can have a lot of a negative number.
Let me see what is off. You multiply through by negative 0.1. 0.9 to the n. Ah, look, I told you again, it's 0.9 to the n minus 1. You need to bring over the negative 1. Bring over the negative 1 so that become plus 1 there.
Okay.
Yeah, that line. Very good. Equal to 22 years. I'm glad he didn't go ahead and put 2016 because I've seen persons go and put, say, this would happen in 2016. That's not what the question wanted. The question wanted how many years from the start to now, and you did that correctly. Very good. So
Wait,
now,
is a past paper question?
no, these are higher level questions. There's only 6 years of past paper, you know. So the thing is, they don't have a structure as yet. Do you get what I'm saying?
So yeah.
There's no real structure, meaning if you look at the sequence question in 2016, it's completely different from the sequence question in 2017, which is completely different from 2018. And then 2019 and 2021 was just really easy, way easy in comparison to the first 3 years. So it's only been 5 paper 2s because the paper started in 2016. So therefore, you cannot just do past papers and think that that is sufficient for integrated math. What you want to do is overall do enough questions on everything under the syllabus, right?
That's around so.
Yeah, once you cover everything under the topic, then it doesn't even matter which type of question they give you, because you'd have covered all the concepts. But whenever we finish the entire syllabus, we're going to go through all the past papers because I have every past paper up to 2019. So I just need to get 2021 paper. Because you know, 2020 didn't have a paper too, right?
So
2020 was COVID year. So I just need to get that paper. And once you finish everything, I'm going to let you do the full paper. And then, of course, I mark it. And then anything where there's mishaps, we go through. So don't worry. You're going to be sure to get your distinction. All right. But now we're just doing the core contents. All right.
so
All right. Let's do a AP worded problem now. Need one that's increase in sales. Notice here, you see these questions are taken from 1990 odd. That's because they're not even CAPE. They're not CAPE math. They're not CAPE integrated. These are questions from GCE. They're GCE math. This is mathematics that would have done before CAPE started. But the principles are the same.
It's supposed to be 200 more than in general.
Yes, ignore that full stop.
Right.
Sorry. Yeah. Ignore where you keep seeing the full stops before the more.
Uh, This is arithmetic.
Yes, it's arithmetic. Very good, Jamie. To remember, there are only 12 months in the year. Very good. Sharp. I'm happy to see that. Good, good. The common difference is 200. All right, don't write January equal 2,100. The month can't equal 2,100, right? January sales, or just write something regarding the sales of television set, just so it makes sense. Very good. That make more sense. All right, very good, very good. All right, so we're gonna do one more of these questions, but I'm not gonna tell you which type it is. But before we do one more of these questions, I'm gonna give you a CAPE question, just so you know you can see the big difference between what transpired in CAPE. So this question I'm gonna give you, this is the 2015 specimen paper. This is 2015 specimen, and it was worth 4 marks. By the way, it was worth 4 marks. If you want to know how many marks it was allocated, 4 marks in 2015.
I feel like I can equate these somehow. Um,
So you have 2 equations and 2 unknowns. What's coming to your mind? If you were to see X and Y, what would you do?
I would do a simultaneous.
Exactly. So do a simultaneous equation. -122, -4. So state the first term. All right, something is off, Jamie. So I need to look back and see where it's off. I'm just going to share my screen for a second. I'm going to let you see right here. So this was the specimen solution. And as you can see, your equations are correct. A plus 7D and A plus 52D. But as you can see, look how the marks are distributed. You get 1 mark for this equation and 1 mark for the next equation. They don't care about your working, but then you solve simultaneously and they're going to give you 1 mark for the 178 and 1 mark for D to be -4. So all of that step that you're showing you're working, what they're saying is you should know that from CSEC. So you realize they mean with the marks, don't it?
Yes, sir.
All right, so share back your screen now so I can see where was off. Let me see what happened. All right, what happened here? The two equations are correct. You subtract 7 minus 150 minus 30 is 180. Divide by 7 minus 52. 180.
Oh, I subtracted it.
Oh,
Adding
180. 180 divide, that's -4. Plug in the -4. Yeah. Should be adding it. Can't give it away. Can't give it away. All right, so I've gotten 3 out of 4 and not the 4 out of 4, but we don't want to give it away. All right, now, are you ready for Trinidad specimen paper question? I don't know why Trinidad's so special. So Trinidad, they gave a different specimen from the rest of the Caribbean. So let me give you Trinidad specimen. This one was worth 6 marks. And it's usually arithmetic progression. That's so boring. So now you're getting real exam questions. So you see the big difference between the exam question and practice question. But once you do practice questions that are way harder, the exam questions are going to be a lot easier, don't it? Yeah. And this is the Trinidad 2016 specimen paper.
I was saying the progression consists of 101 terms. Right.
Repeat.
They're saying that the progression consists
Yes,
of.
consists, yes.
Right.
So an arithmetic progression, they tell you the first term and common difference consists of, yeah. They're telling you the progression consists of 101 terms.
Hold on, sir. I need to use the bathroom.
Okay.
Boxer.
Okay. Now you don't have to always use the formula, you know, for arithmetic progression. What would be the first three terms? The first term is A, second term is what?
A plus D.
And the third term is?
A plus 2D.
Exactly. So add up those, and that's the sum of the first three terms. And then what would be the last three terms? So you have 101 terms. Yeah, that's right, 98D. And they said the sum of the last three is what? How much times the first three? So yeesh. All right, so remove the commas and put plus, because if sum means plus. When you put comma, that's a sequence. Add them up now to show the sum of all of the year. And what is A?
Is 8.
Very good. Okay, don't throw away the D. It's not S48, you know. They said the last 48 terms. S48 would give you the sum of the first 48 terms.
So I can find the sum of everything and then subtract it from
Very good, yes. Then subtract the other, how many other terms that would be? Then subtract the sum of the other 53 terms, right? All of them minus the sum of the first 53, get the last 48. So you realize the actual exam questions are easier, don't it?
Sure.
Yeah. Very good. 996. All right. You realize it wasn't too bad.
Sure.
All right, good. So how do you feel in comparison to the exam questions or the questions that we were doing before today? The more, yeah.
First one was not this one. This one and this one was hard.
Yeah. So those two were GCE questions. That's before CAPE started. All right. So those were what they did in the 1990s. But the other ones now are just worded problems with money. And maybe another time I'll show you how we can use compound interest formula as well as simple interest formula and get the same answers we were doing with those money questions to show you that every topic in maths is linked. So that show you that maths is beautiful, don't it?
So
All right, so what we're gonna do next week is we'll finish with sequence and series now. So we're gonna be doing matrices. I sent you everything for matrices today, but we didn't get to start. I thought we'd have finished the sequence questions quicker, but no problem. So we're going to be doing matrices next week, all right? And we're focusing on 3x3 matrix. If you look on the syllabus, let me go back to page. If you look on the syllabus, everything is 3x3 matrix. All right, that's what we're focusing on, 3x3. We'll still need to be able to do basic operations with regular matrix, add, subtract, multiply, represent data in matrix form, find determinant, and solve using Cramer's rule. Now, Cramer's rule is what is suggested, but hear what they say. While question will be instructed to make Cramer's rule convenient, other alternative methods will be accepted. So I'm going to show you all three methods, because if you notice in the worksheet that we're going to be doing next week, you're going to see cofactor method, you're going to see row reduction, and you're going to see Cramer's rule. Whichever way you find the easiest, you use, all right? I want to show you all three and you use, but we're going to start with Cramer's rule because that's on the syllabus. But notice the syllabus said other methods are accepted, right?
Yes, sir.
So you can determine which way is easier to you, all right?
All right.
All right, Jamie, so see you next week, Wednesday. We'll go back to statistics, the best topic in mathematics, right?
Thanks, sir.
All right, take care.